So today we will do the two sum problem. So we are given a integer array and a target sum. So and we have to find two elements in this array such that their sum is equal to the target. Okay, so for this example we have the array of numbers 2, 7, 11 and 15, and we can see if we add 2 and 7 we are getting 9. So we'll just return the index of both of them, and you can do it in any order. So that is 0 and 1. So like this we can see the other examples also. In the nums array we have 3, 2 and 4. Target is 6, and we can see that when you add 2 and 4 we are getting 6. So we'll just return the index of index 1 and 2. So that is all right, but the thing is that you can do it in many ways, and the first thing which can come to your mind is the brute force approach, where each time you are traversing through the element, and again you are taking another loop to find another element which will add up to this target sum. So you can use two nested loops and it will take O of n square complexity. Now we can try to reduce that. So we can use the two pointer approach. So one pointer will take at the starting of the array, and another pointer will take at the end of the array, and we can start to increment and decrement the pointers as and when we are required. Okay, so okay. So the first things we need to guarantee is that the array is sorted or not, because if the array is not sorted, then our um, technique will not work. So we'll just sort this array, that is nums. Okay. And we'll use two pointers, int ptr1 equal to 0 and pointer 2 which will point to the last index, that is nums dot length minus 1. Okay, and we'll have a while loop. uh, it will continue until ptr1 is less than ptr2. So now we'll check whether if you add them. So suppose if ptr sorry if nums ptr plus nums ptr2, that is equal to your target, then we have our job done. If this is the case, then we have our job done. Okay, so in this case we'll just return an array of these two pointers. So return new int, and we'll just return these two pointers, and if it is not equal, then either it will be greater than target or it will be less than target. So ptr1 plus nums ptr2. So if it is less than target, that means we need to increase the sum. So if we need to increase the sum, that means we can increment ptr1. So if we increment ptr1, as we are sorted in ascending order, we'll get more greater element and the sum will increase. So that's why we should increase ptr1. And in the else part, only one thing is left when the condition nums ptr1 plus ptr2 is greater than target. So if it is greater than target, we need to decrease the sum, and if you want to decrease the sum, we can decrement this ptr2 pointer, because ptr2 pointer is in the later half of the array, and if we decrement it, we'll have less elements because it is sorted in the ascending order. So we'll have ptr2 minus minus. So this thing will continue, and when we have come out of the array, we should return something, because we know that it is guaranteed to return here, but the compiler doesn't know that. So we need to just return some dummy values like new int, and to return like suppose -1 and -2 index, which doesn't even exist, because we know that this statement will not encounter, and if it does encounter, that means we have made some error in our code. So let's run it. So we have got correct answer for this one, so let us submit it. Okay, so wrong answer for this value. Okay, so we have to return the original index and not the index after we are sorting. So we need to keep track of the original index. So for that we can make a class like group. I'll group the index element with the actual element. So x, this will have the element, and we can have the index, and we will give a constructor, so that is x and index. So I'll initialize like this dot x equal to x, and this dot index equal to index, and we will not sort this array, we'll sort something else. So we'll just make a group array. So group arr equal to new group, and the length will be same as length of these nums, and we'll go through every element of this array dot length I plus plus, and here so ith element will be new new group, and here I will pass the nums I and the index of it, so that is I. So we are grouping the index with the element, and now we can sort this array. So that is collections dot sort, and I'm sorting this array, and we have to give a comparator. We are giving a lambda expression to define how our elements will be sorted. So I'll sort only on the basis of the element. So a dot x minus b dot x, so it will be arranged in ascending order according to the first x element of this group. Okay, and here we have to use not nums, we have to use the group array. So not nums, we have to use array ptr dot x, and here also use array ptr2 dot x, and we'll just return arr ptr dot index, because we need to return the original index, and here also arr ptr2 dot index, so we'll return the original index, and else here also we need to change that, so dot x, and here also dot x. Okay, and now it should be good, so let's run this code. Okay, no suitable method found. I think we should use a import statements util dot star. Let's see. Okay, so I think for array it will be it will not happen, so I have to make this an array list, I guess. So array list group equal to new array list, and here we need to give dot size, and here we have dot set. Okay, and now we need to do this collections dot sort. It is okay, and then here we need to write dot get tr dot x. Here also we'll have to write dot get ptr2 dot x, and here also we have to write the same thing. Okay, and here also. Okay, now I hope it is okay. Okay, so we have got another error. We can just do like add and this. I hope it will be correct this time. Okay, so not array dot size, so that is now nums dot length, so that is better. Okay, so now we have got accepted solution. We need to submit it and see it's working. Okay, so now it's accepted. And for the time complexity, so we are first traversing through all the elements of the array to form this group array list, so that will be O of n, and we are sorting it, so that is n log n, and again we are traversing to maximum every element once, so that is your O of n. So O of n plus log n plus O of n, so that is equivalent to your n log n. So that is it.